All right, in this video, we're going to start looking at how to solve equations. So we're only going to focus on the additive property of equality. We're going to look at whole numbers, decimals, integers, and sign fractions. So we're going to kind of look at four different types of numbers, but we're looking at the additive property in each one, and I'm going to explain what that means here. So we're going to use PEMDAS. So remember, this is something that does not go away. Please excuse my dear Aunt Sally, which stands for parentheses, exponents, multiplication, division, addition, subtraction. And it's just a mnemonic to help us remember the order that we need to do things, the order of operations, to simplify an equation. It's actually, we're simplifying the expression, you solve an equation. So before we solve the equation, we want to make sure it's simplified. These are all one step, so they really should already be simplified. Once we have simplified as much as possible, then we can solve an equation for a specific variable. Okay, so we use inverse or opposite operations to get the variable alone or isolated to one side of the equal sign. So we're trying to get it by itself. Inverse or opposite operations, addition and subtraction, so those are opposite operations, or we have multiplication division. So we'll deal with multiplication division on the next video. This time we're only going to deal with addition and subtraction because we're looking at the additive property. So that's kind of the connection there. So identify what is being added or subtracted from the variable. So if we look here, this is kind of the little hint box on, what are we going to be doing. So we have solve for u minus 7 equals 8. So we're subtracting 7, right? So I have the negative 7 is 7 is being subtracted from the variable. I don't want to say negative 7 is being subtracted. That's switching it to a double negative. So we're going to use the inverse or opposite operation to move it to the other side. So the operation that we want to use, if it's being subtracted, we want to add. So I'm going to say plus 7, and really what I'm doing is I don't want to know what u minus 7 is. Something happened to the u, I'm taking 7 away from it. I want to add the 7 back so that I know what it was to begin with. It's like a little investigation to go back to the beginning. Okay, so I have u, because I haven't done anything to it, it just drops down. 7 minus 7, so even though I'm saying them upside down, it's a negative 7, it's a positive 7, they cancel out. That is what we want to happen, because we want to move this 7 to the other side. So I have 8 plus 7, which gives me 15, and that is a u, looked almost like a 4. So u is 15. And in a lot of these cases, I can probably look at this and say, what would I need to subtract 7 from to get 8? And I might be able to go, oh, it's 15. Single step equations tend to be a little bit easier to just picture and figure out without really having to do this process. But the more we practice this process, the easier it'll get later when we're doing 3, 4, 5 steps. And we can't just do that in our head, because we're going to get to the point where we really have to simplify a whole bunch, and then we're going to have to do a couple steps to get the variable by itself. So it's not going to be as easy as, oh, I can just fill in the blank with the number, because it's one step. So make sure you're practicing the process. All right, so now we have our decimals. So we have y plus 5.5 equals 7.17. And I know decimals tend to not be everyone's favorite, but honestly, our lives live in decimals, okay? We very rarely deal with whole numbers when we're dealing with real life numbers. And for the most part, what I'm talking about is money, because that's where we deal with numbers the most in our real lives every day. We generally deal with money or time. And very rarely does money come out to be whole numbers. We very rarely just have $7 and $8. It's usually going to be something like this. I have $5.50. I have $7.17. So decimals are a very important part of our lives, and we want to make sure we understand them. All right, so we're going to identify what is being added or subtracted from the variable. So I can see that I'm adding 5.5. So I'm going to use the opposite operation to move it to the other side. So the opposite operation is subtract. So we're going to subtract 5.5 so that I can undo. I added 5.5 to y to get 17.17, but I want to know what was y to begin with before I added the 5.5. So I take it away, and that cancels. And I'm going to add this, and I'm going to get, let's see. Oh, I should have written this a little bit nicer. So here, I'll rewrite it here. When you're doing decimals, make sure that you line up your columns. And with this one, it's $5.50, right? So there'd be a 0 there. So make sure you always line up your decimal. And then if you don't have any numbers there, you fill it in with zeros. So the 7 comes down. I would borrow here and give that over here. So I'd have 5, and then 6 minus 5 is 1. So I'd end up with 157. Uh-oh, did I do that wrong? Let's see. I want to make sure I didn't mess. Oh, that should have been an 11. Ha ha ha, because there was already a 1 there. So this should be 6. So I did do that wrong. There we go. 167. All right. Does everybody make mistakes? Of course, everybody makes mistakes. Just go back and look. If you made a mistake like that on Alex and you checked it and it said that is incorrect, try again. You just go back. You can either redo your math, or you can go back and look through your math and say, uh-oh, what did I do? And find your mistake. It's totally normal. All right. So now we have solve for y. 9 plus y equals 3. So integers, that's the third one we were practicing. Integers just means it can be positive or negative. It's not just whole numbers. We did have a -7 here. So really, these two are kind of the same practice, the first one and the third one. So identify what is being added or subtracted from the variable. So we are adding 9. So this one confuses students just a little because we have the plus y. That belongs to the y. So be careful about that, because I have seen it written like this. And then students go, oh, I'm subtracting 9. No, you're subtracting y from 9. So that sign belongs to the very next number. Okay, so be careful about that. This one's not too bad, because even if you made that mistake, this is still a positive 9. So it's, pretty straightforward on this one. It's not as easy to make a mistake, but make sure you pay attention to that negative sign. It belongs to that very next number. Okay, so with this one, I'm adding 9 to both sides because it's positive there. So the opposite operation would be to subtract. All right, so I'm going to subtract 9. Opposites cancel, and the y drops down. The equal sign also drops down. I don't know if I've said that on the other two, but make sure I still have students that kind of make that mistake there, where if you haven't done anything with it, you bring it down, because we still have to do something with that, or it still represents something. So that y equals comes down, and then we have 3 minus 9, and this is where I like to look at algebra tiles, because some students still get a little bit confused with the idea of integers when we're subtracting. All right, so if I have -9, and I'm going to put those in red, 1, 2, 3, 4, 5, 6, 7, 8, and that should give me 9. 1, 2, 3, 4, 8, 9, perfect. So these are all negative ones. So I have -9. I have 9 tiles here, and then I'm going to do +3 tiles. So those are in my yellow there. So here's my +3. All right. So in algebra tiles are super easy to draw. You just saw me do that. Or some of the centers may actually have the algebra tiles for you to manipulate and mess with. If you're having any trouble with adding and subtracting integers, use the visual. It makes it much easier to see what's happening. So I have 3 minus 9, so -9, +3, and you cancel out one tile to one tile. So I go like that, 1 to 1, 1 to 1, 1 to 1, until I have nothing left to cancel, and I say, okay, what's left over? So I have -6 left over. So my answer is -6. So another way to look at this is, if you're not super happy with the algebra tiles, if that's not working for you, what you can do is just say 9 minus 3, and that will get you 6, and then you need to look at the original problem. Which one was negative, which one was positive? The 9 was negative. 9 is bigger than 3, so I have -6. I have more negatives than positives. because 9 is more than 3, so I have more of them. So that's another way to look at it too. You can just subtract the numbers from each other and then which one was bigger. That's the sign you want to use. All right, let's go ahead and look at our last one here for fractions. So we don't deal with fractions as much in our everyday lives, but they are still very present, especially if you do anything with baking or cooking in general. That's honestly where I use them the most in my life. It usually has to do with cooking, and I'm excluding math class because yes, I use all of these things much more often than probably the average person because I'm teaching them in math class. But I do use fractions quite a bit when I'm cooking and baking and doing those things. All right, so we're going to simplify our answer as much as possible on this one. So we have x minus 3/4 equals negative 1/3. So identify what is being added or subtracted from the variable. So I can see I'm subtracting 3/4. So I'm going to do the opposite operation. I'm going to add 3/4 to both sides. So I'm going to go plus 3/4 plus 3/4. So this is where it gets a little tricky with fractions because the excess comes straight down. Negative 3/4 plus 3/4. Well, just because they're fractions doesn't change the fact that it's a negative, a positive, it's the exact same number. They do in fact cancel. So that part's still pretty easy. But this part is where it changes a little. So I'm going to bring it up here. So I'm like, this is what I look like right now. Negative 1/3 plus 3/4. When I'm adding or subtracting fractions, I need to have the denominators like. Basically, what a fraction means is how many pieces do I have of this. So if I were to draw this one, I have 3 pieces. Like this. 1, 2, 3. That's how many were available. And then there's one, it's negative. So this actually I should have drawn in red probably. So it was negative 1/3. So I'm kind of deficient 1/3. I'm missing it. And for this other one, I would have 4ths. Like this. So actually I'll draw it right underneath there so you can even see it. So 4ths, come on, draw. Like this, and I would have like that. So here's 4 pieces, and I have 3 of those. Why is it drawing funny? It's because it's at the bottom of the screen, that's why. Let's see, I'm going to move it up. So I have 1, 2, 3. So the reason we need to make the match is I can't really compare these. If you notice that top one, this is 1/3 and it's going through part of the 4th here at the bottom, right? And I didn't draw this super accurately, but this is 1/3. Well, how do I compare that to the 1/4? So that's why we need to make them have the same denominator. So they represent the same size pieces of the whole. We have a whole number for both of these. They both represent a whole number, but I only have a certain amount of that whole number. So that's kind of, the quick version of fraction tiles, which is another thing we may have in the centers. You can always ask, because sometimes we do have those. All right, so to make them like denominators, what we want to do, the easiest way to do it is just to multiply by kind of the denominators together. So I have 3 times 4, and I get 12 and 12. This first one's still going to be negative. So now what I want to do is if I multiplied 3 times 4 to get 12, I want to do the same thing at the top. 1 times 4 is 4. And then on this one, 4, to make that 12, I multiplied by 3. So I'm going to do the same thing on top. 3 times 3 is 9. So now I have the same size pieces. And I can actually look at these in algebra tiles again. Let's see if I can nicely draw this. This one's a little bit bigger. Let's see. So I have 1. So that's 4ths. And then let's see. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10. This is not coming out very nicely because I did not plan it out very well. There we go. We have 12 there. So it's negative, or here's 12. And on the top, I have negative 4. So I'm going to go 1, 2, 3, 4. And on the second one for the top, it was 9 of them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So I'm still talking about 12ths. It's still parts of a number. It's not whole numbers. So I still have 12 on the bottom, but I want to know how many parts do I have. And these parts where they mixed, and I did that on purpose so I didn't have to draw 2 of them, we cancel those out, just like we did with the algebra tiles. So what I have left is 1, 2, 3, 4, 5 twelfths. So I have equals 5 twelfths. So again, it's just kind of a practice in that idea, making sure that you understand, what does a fraction actually represent, and then practicing that idea. And using visuals, definitely recommended. It makes it much easier to understand what's happening if we can draw a little picture. All right, so that was using the additive property for solving one-step equations. And we practice it with decimals, integers, just whole numbers, and sign fractions. So go ahead and go on, Alex, and give it a try.